The crosses that we have been talking about so far had to do with alleles that were carried on autosomes, which are most of the chromosomes in your body, but you do have sex chromosomes, and those chromosomes determine what sex you are. There are also other characteristics that are carried on those sex chromosomes, but an X chromosome is much longer than a Y chromosome is. A Y chromosome doesn't have room for as many genes on it, and so therefore there are some characteristics that are going to be carried on X chromosomes but not on Y's, just because of the length of the chromosome. We're going to do two different examples today. One is in the book and one is not. And both of the examples that we're going to do have to do with fruit flies. And you may be going, who cares about fruit flies? But the same principles are going to carry over to people, because a lot of diseases are carried, or the possibility for certain types of diseases or conditions are carried on sex chromosomes. And so that means that males and females have a different chance of inheriting them depending on whether their parents are carriers or not. And I'll explain all that more in just a second here. First of all, we're going to look at example 7.7. And in fruit flies, red eyes are dominant and white eyes are recessive. And so example 7.7 says a heterozygous red-eyed female. So let's take that piece of information right there. I got a heterozygous red-eyed female. If it's a female, I already know that it's going to have two X chromosomes. But the alleles for eyes are what it's heterozygous in. Red eyes are dominant, so that means it's going to have one dominant and one recessive. Okay? Then it's going to be crossed with a red-eyed male. Well, a male has to have both an X chromosome and a Y chromosome. If he's red-eyed, that means he's only going to have the dominant allele. Okay, so I can cross these guys now. And let me move that over a little bit so that it's going to be a little bit neater. Okay, now when I cross these, I have to look not only at the alleles, but I have to look at the sex chromosome as well. So this offspring is going to have two X's, and they both are going to have capital R's on them. This one is also going to have two X's, but one has a little r and one has a big R. Down on the bottom, I'm going to have X's and Y's. So this X will have the dominant allele with a Y, and this X is going to have a recessive allele with a Y. Okay, so when I look at phenotypes for this type of cross, I also have to look at not only the trait that I'm studying, but I have to look at whether it appears in males or whether it appears in female offspring. Now, as you can see here, 50% of my offspring are females and 50% of my offspring are males. So if I look at my females first, what color are their eyes? Well, in this female, I have two dominant alleles, and so this one is red-eyed. In this female, I have both a dominant and recessive, but the dominant rules. So all of my females are going to have red eyes. Now the question did ask us, what is the percentage of getting a white-eyed female? Well, did I have any females that have white eyes? No, I do not. So 0% of females are white-eyed. Okay, now what about my males? Well, this male has what color eyes? Red, but this male has white eyes because he carries the recessive allele. You notice that if they get the Y chromosome, that characteristic doesn't carry through at all on that particular chromosome. And so whatever the mom has, that's going to be coming through in the male offspring. So here, 1 out of 2, or 50% of my males are white-eyed. So you can see that if I have a sex-linked chromosome, then a sex-linked trait, then what's going to happen is that it's going to show up more often in males than it's going to in females. And so that's going to be particularly true if you have diseases that are carried on sex-linked chromosomes. All right, we're going to do one more example. Again, this one's not in your book. I just want to show you a different type. Okay, let's say that I have a homozygous, red-eyed female. And I'm going to cross that with a white-eyed male. What's that going to look like? Okay, so my female is going to have two X's. She is homozygous, means they're both the same, and she has red eyes, and so that means she's going to have the dominant allele on both of her chromosomes. The male is white-eyed, so he's going to have an X and a Y because he's a male. The allele for that's only carried on the X, but he's white-eyed, so he's going to have the recessive one. Okay, so now let's do this cross and let's see how this makes a difference. Okay, so here I'm going to have an X with a capital R and an X with a little one. I'm going to have the same thing here. Here I'm going to have an X with a big R and a Y, and I'm going to have an X and a big R and a Y. Okay. How many of my girls have white eyes? How many of my females have white eyes? None of them. They're both white. I mean, they're both red. They both have red because they both carry that dominant trait. How many of my males have white eyes? Again, none of them, because they both carry that dominant trait that they got from the mother, right? So in this case, I have no white-eyed offspring. The fact that the mom carried the dominant trait for both of them in both of her alleles meant that that's all that her offspring were going to get. Even though the females are carrying the allele for the recessive trait, it's not expressed in any of them, okay? So this is what a carrier is, because now if these will go and reproduce, depending on the male that they reproduce with, it's possible that they may end up with some white-eyed offspring because they carry that small r. So they are carrying the trait. That's what a carrier is. They're carrying the trait, but they're not expressing it. Okay? So depending on where those traits end up, in the first example we did, you could see that more males ended up with it than females, but in the second example, you could see that none of the trait that carried through as a phenotype in any of the offspring. Okay, so those are sex-linked traits.